Alrighty, so 14.30 part B asks us to find the velocity and acceleration when our position is given by positive 9 centimeters. So let's just go ahead and convert that to meters right now. Which is positive 0.09 meters. So now, what we want to do is find our velocity, which from a previous problem, we were able to manipulate the equation for amplitude to find our velocity at a given point. So rather than just going through the manipulation right there, I'm just going to write it down here, and you can refer back if you want to for how to do this. So that is going to be our angular velocity times the square root of our amplitude squared minus our position squared. So now we can just plug and chug all these in. We know our angular velocity from part A as 5.34 radians per second times the square root of our amplitude, which is 0.18 meters squared, minus our position, which is 0.09 meters squared. So now, should probably do that so it's more clear. So that's going to be our 5.34 radians per second times the square root of 2.43 times 10 to the negative 2 meters squared. And then when we do this square root here, that's going to take that down to meters, and the final product will give us meters per second, which is what we're looking for, so we know we're on the right track. So that velocity, once we go through all this math, is going to be 0.83 meters per second. And then our acceleration is actually pretty simple, which is nice because we're running out of room. So acceleration given our position is negative angular velocity squared times the position itself. 4 squared times 0.09. Oh, and that's going to come out to be negative 2.57 meters per second squared. And we have these units just because we know that our position, this is given in meters, and our angular velocity is radians per second. So that's going to be per second squared once we add the square in there. And then we'll do part C in the next video.